All right, this video is for Unit 6, Section 5 notes, last notes of this unit. Let me see if I can get this to focus up a little bit. Okay, so polynomial applications, where we're going to see this stuff in the real world. So polynomial functions are used in engineering, computer, and math-based jobs in management, business, and even in farming. So here we go. Farmer Frank is planting a garden this fall. He wants to plant squash, pumpkins, corn, beans, and potatoes. All dimensions are in feet. His plan for the field layout in feet is shown in the figure below. Use the figure and your knowledge of polynomials, perimeter, and area to solve the following. All right, write and simplify a polynomial expression that represents the length of the south side of the field. South, south. So the length would be adding all these up. Okay, all that is combining like terms. And I know it's kind of hard to see these numbers on here. All right, so x squareds. I've got two of them. So 2x squared. X is 5x and negative 7x makes a negative 2x. And then constants. Positive 2 and negative 9 gives me a negative 7. Plus a positive 12 gives me a positive 5. Okay. Why might it be useful to know the side length of the field? Maybe to know how much fencing is needed if you need a fence in a side. Okay. Write and simplify a polynomial expression that represents the area of the potato field. Potatoes. This side times this side would be area. So x plus 6 times x squared minus 7x plus 12. So you can use the box method for this. I'm just going to multiply it out really quick. So x times x squared is x cubed. X times negative 7x is negative 7x squared. X times 12 is positive 12x. Multiply by the 6. 6 times x squared is 6x squared. 6 times negative 7x is negative 42x. 6 times 12 is 96. Hang on, that doesn't sound right in my head. Doesn't sound right. 6 times 12. Oh, 6 times 12. Try that again. 72. Sorry. I don't know where 96 came from. Plus 72. And then I can combine my like terms. And that's the area. State one reason why the calculated area would be useful to Farmer Frank. To know how much space is needed, or how much space there is to plant potatoes. I don't know if you guys know anything about gardening, but it tells you how many of a plant you can put per square foot. Okay. So yours looks different than mine does. Here's what mine looks like. Okay. My daughter's laughing at me, y'all. So let me grab my other notes because these are identical to the notes that we did in pre-cal. So let me grab those so we can get these filled out. Sorry, gotta hunt them down. Okay, here we go. A trunk is constructed from a 16-foot by 20-foot sheet of material in the following manner. Find the material, or first the material is folded in half by forming a 16 by 10-foot double sheet. Then 4 equal squares of side length X are removed from each corner of the folded sheet. The material is then unfolded and a box with sides and a lid are used to form a trunk of maximum value. So here's what the material looks like cut out. Here's what the completed design looks like. Okay. So here's what we know. It says a trunk is constructed from a 16 by 20 foot sheet of material. So that means all the way across here would be 20 feet. all the way across here would be 16 feet. Okay. First, the material is folded in half, forming a 16 by 10 foot double sheet. So this is still 16 all the way across here. And so when I say all the way across here, so if I cut this thing in half, I'm meaning from here, skipping this gap all the way across, and that gap is 16 feet. So this distance here in the center. Okay. 4 equal squares of side length x. So that means this distance here of what we removed, these are x's. Okay. So if the total distance here is 10, and I got to subtract an x here and subtract an x here, this little piece would be 10 minus 2x. If this distance from this corner here to here is 16, I'm doing the same thing. I'm subtracting an x here and I'm subtracting an x there. So 16 minus 2x. Okay, so it says write a function that can be used to determine the maximum volume. So on this piece here, this is an x and this is an x. Okay, those are where the notches were cut, which means this distance here is the 16 minus 2x. This is the 10 minus 2x. So volume equals length times width times height. The length is 10 minus 2x. The width is 16 minus 2x. And the height is x. So we would multiply all of these together. So how I would do that, I would FOIL this piece first. So 10 times 16 is 160. 10 times negative 2x is negative 20x. Negative 2x times 16 is negative 32x. And the negative 2x times negative 2x is a positive 4x squared. Then multiply by that x. I left the x for the end because all I have to do is just add an x on to all of these. Bump the exponent up. All right, writing it now in, oh, I did that wrong. The height should be 2x. I lied to you. Now she's gasping at me, y'all. So this would be, because there's x and x. Okay, this would be 320x. This would be negative 40x squared, negative 64x squared, positive 8x cubed. Simplifying it down, writing it in proper form. So if I combine these, I get negative 104x squared and then plus 320x. State the realistic domain and range. So x is a measurement. So the notch that's cut out, maybe the height. And then y is the volume. Okay. So for my domain, the smallest the height could be is 0, right? And even then, I would probably use a parenthesis because you couldn't have a 0 height. It would have to be something greater than that. The biggest that amount could be, we would set this equal to 0, right? We would do 10 minus 2x equals 0, and we would solve x equals 5. And we would do it for the other side as well. And x would equal 8. Okay? Meaning, this little notch we cut out can't be bigger than 5 feet. If it's bigger than 5 feet, it takes the entire side. There's no longer a notch there. So again, that would be a 5. And again, I'm going to use parentheses. Because again, if we use that total 5, it won't work. So our range is going to be from 0. And then the biggest volume that we could have so that's actually this next question. So we're going to do this next question. So the maximum is going to be the vertex of this thing. Okay. And it's the y value of the vertex, the highest point that it reaches. Okay. So let's look at this. If we graph what we have here. The other way that you can do this, we know the max x value is 5. So we could also do it this way. Plus 320 times 5 Oh, it still gives us 0. Okay, so let's look at the graph. So 8x cubed minus 104x squared plus 320x. Graph this thing, zoom out. And so I don't know if you can see it. Zoom, do a box here. But it's this area. It's right in this area here. This is the vertex we're talking about. So I can find the maximum. That's the maximum volume right there. So that x, if x is at 2, it's going to give me the maximum volume I'm going to get out of this, which is 288 feet cubed, which also tops out this. Now, for this, I would use a bracket because I can get a volume of 288. Okay, so what are the dimensions which will yield the maximum volume? So we just looked at that, and that vertex was at 2, 288, which means x equals 2. So my height, and so same with this. This is where I messed up in this. Should have been 2x. My height is 2x. So 2 times x would be 4. The length is 10 minus 2x. So 2 times 2 is 4. 10 minus 4 is 6. And then width is 16 minus 2x. 2 times 2 is 4. 16 minus 4 would give me 12 feet. All right, so that is it for this last set of notes for this unit.